Hello everyone. Now today we are going to see the Freudensteins equation which is applicable for four-bar chain mechanism. Now this is the analytical method so as to synthesize the four-bar chain mechanism. So now in Freudenstein equation here, this is the four-bar chain mechanism in which the link AD is fixed, then link AB is the crank, BC is the coupler and CD is the rocker. Now this four-bar chain mechanism, now it is represented in the planar. So this mechanism is called as planar mechanism. Here, the A is the vector representing the AB link, B is the vector representing the link BC, C is the vector representing the link CD, and D is the vector which is representing the link ED. Now, the angle inscribed by the crank with respect to fixed link is theta. The angle made by the horizontal by this link BC is beta, and the angle made by the output link or rocker link with the fixed link is phi. Now all these link lengths now we can represent it in the vector form by resolving these links into x and y axis. Now suppose if you try to resolve this link AB in x axis and y axis, now this is a cos theta along x axis and a sin theta along the y axis. Similar for this link BC, b cos beta along x axis and b sin beta along y axis. And for C, means for link CD, it is c cos theta along x axis and c sin phi along the c cos phi along x axis and c sin phi along the y axis. Now we have to just take the summations of x and y axis corresponding x and x vectors along the x axis and vectors along the y axis. So for the equilibrium condition, by taking the summation along x and y axis, you will get these expressions. Now after getting this expression, you have to square from both the sides. So we'll get this part. Now this for the x-axis and this expression is for the y-axis. And on doing the summation for second and fourth equation, we will be getting total this equation. So by substituting the values, finally you will get the constants for K1, K2 and K3. So K1 is nothing but the length of link is D by A, K2 is D by C and K3 is A square minus B square plus C square plus D square upon 2 times of AC. And the Freudenstein equation is K1 cos phi minus K2 cos theta plus K3 is equal to cos of theta minus phi, where K1, K2, K3 are the constants. Theta is the angle made by the crank and phi is the angle made by the output link with respect to the horizontal. So in this way, we are getting the Freudenstein equation. Now, as this Freudenstein equation is applicable for the four-bar chain mechanism, now we will go to see the next concept which is related to four-bar chain mechanism, that is the coupler curves. So what are these coupler curves? So coupler curve is nothing but the points on the coupler link, means whatever the path traced by the points, each and every points on the coupler link is been given by this coupler curves. Now for example, in this diagram, if you see, this is the four-bar chain mechanism in which link 1 is fixed, O2 point is fixed, O2A is crank. This bigger part is nothing but the coupler, which is attached to another point at B, and O4, this O4B is the output link. Means link number 1 is fixed, link number 2 is crank, link number 3 is coupler, and link number 4 is the output link. So coupler is nothing but the link which is connecting the input and output link for the four-bar chain mechanism. So now this coupler curves, there are different types of curves for coming under this category. So that is here, if you see, the four-bar coupler curves comes in variety of shape. So what are the shapes? So there are two types of shapes. One is curves and kernel. So what is this curves and kernel? So if you see here, this is the pseudo ellipse. These are the shapes of the curves. Here, this profile means this part and this point will be tangent at this point. So these are called as curves. And all the points which are having intersecting this profile are known as kernel. So curves are observed is at which the tangents are coincident. So here the tangents, they are coincident. These curves which are generated in such a way that they will be tangent at one point. So at that point is called as curves. And where that they are intersecting or they are coincident, they are known as kernel. So these are the two profiles which are generated by the coupler curve. So now how the curves is generated? Means here if you consider one circular ruler is there and it is ruling on a flat surface. If you consider any point P here, so whatever the path that particular point is traveling when this ruler is moving, so that profile generated is nothing but what is called as curves. And what is the kernel? When we see four-bar chain mechanism, the look is here, the centroid is moving. Now here this is the point. So this is another point, this is another point. So this is what are the path they are traveling, and at that point where they are tangent to each other, so we'll get C1, then C2 and C3 and so on. So at that point only we will be getting the cups. And what is Carnot? So Carnot is nothing but what? Intersecting point. Where the tangents they are intersecting. Suppose now this is a Turner link. This is a 4-bar chain mechanism in which the coupler is replaced by, from instead of binary, it is now a Turner link. So whatever the point this EM is traveling, they will be cutting at each and every point. So whatever the points we are getting, these are nothing but the Carnot point. So this is the basic difference between cups and Carnot. Thank you.